welcome to this IChemE Global Awards webinar. My name is Matt Stalker and I'm your host for today's presentation. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely recognised as the world's most prestigious chemical engineering awards. Today we'll be announcing the winner of our top prize, the IChemE 2020 Outstanding Achievement in Chemical and Process Engineering Award. Many of you will be attending an IChemE Awards webinar for the first time, but today's presentation is the culmination of our 2020 awards programme. In recent weeks, we've presented 20 awards and welcomed 133 finalists. With more than 1,000 webinar registrations, the series has been warmly received by our members and the wider chemical engineering community. But today is about recognising the best of the best. All of our 2020 Team Award winners are in the running, so let's take a look at the contenders. We have Engineers, winners of the Best Consultancy Award. Fujifilm Diosynth Biotechnologies, winner of the Biochemical Engineering Award. The University of Hong Kong, winner of the Business Startup Award. WSP, winner of the Diversity and Inclusion Award. Johnson Matthey, winner of the Energy Award. Biocatalysts, winner of the Food and Drink Award. Johnson Matthey, winner of the Industry Project Award. Plastic Energy, winner of the Innovative Product Award and the Sustainability Award. Saudi Aramco, winner of the Oil and Gas Award. GSK, winner of the Pharma Award and the Process Automation and Digitalisation Award. Advanced Analysis Australia, winner of the Process Safety Award. The University of Strathclyde, winner of the Public Engagement Award. The US National Energy Technology Laboratory and West Virginia University, winners of the Research Project Award. The Centre for Process Innovation, winner of the Team Award. Sellafield Limited, the Office for Nuclear Regulation, AWE Aldermaston, Dounreay Site Restoration, the National Nuclear Laboratory, and Urenco Capenhurst, winners of the Training and Development Award. And finally, Aquabee, winner of the Water Award. Recordings of all our previous Global Award webinars will be available on the IChemE YouTube channel shortly, where you can find out more about all of our winners, highly commended entries and finalists. And before we move on, I'd also like to thank all of our 2020 awards sponsors. It's their support that makes our awards programme possible. But now, to announce the award winner, I'd like to hand over to IChemE President Stephen Richardson.
Thank you very much indeed, Matt, for that introduction, and I'm delighted to be with you all today, at least spiritually. I'm particularly delighted to be having the honour of announcing the winner of the Outstanding Achievement in Chemical and Process Engineering Award, which I will do very shortly, but just a few words before that. Seeing all the excellent work that's been carried out by the finalists, and I've been watching most, if not all, the presentations, I'd like to congratulate you all for the commitment to our profession that you're displaying. It's a profession I'm really proud to be a part of, and I think you're doing us proud by the work you're doing. As all of you here today know, I guess, chemical engineering really does matter. Its advancement to all sorts of things in society is visible in every house, street, factory, school, high street, wherever. And it is my firm belief that chemical engineers are ideally placed to address the global challenges facing communities all around the world in every part of it. And your work, all of you, is contributing significantly to this, and you should be very proud of it. And I know I am, and the rest of IChemE are very proud of you. Now, the IChemE Global Awards, which we're celebrating today, enable chemical engineers from around the world to recognise their peers' significant achievements in tackling the global challenges and developing solutions that's going to have a real impact on all of our lives. And this has been demonstrated, to my mind, really superbly by the finalist presentations that we've shared over the last 3 weeks. I've enjoyed all of them. It was really wonderful to hear about the various innovative projects and solutions that addressed a vast array of issues, some of which I came to for the first time in some senses, but the issues environmental, social, economic, technical. And now, before you get too bored, just before I announce the winner, I'd like to thank the judging panel who, using their vast experience over many years, spent a lot of time reviewing each finalist's submission. And I know the chair of the judging panel has said that identifying an overall winner was like trying to pick a favourite child. all of the winners, all of the finalists, I beg your pardon, were indeed worthy winners, and congratulations to all of you. But there has to be one of you who's the winner of the winners, and so to the matter in hand, it's time for me to announce the winner of the IChemE 2020 Outstanding Achievement in Chemical and Process Engineering Award, which is sponsored this year by the Chemical Engineer. And the winner is Plastic Energy. Many congratulations to Plastic Energy and to everyone associated with their winning entry. Your project, called Closed Loop Chemical Recycling, it really is a world first at commercial scale. You've developed a process that enables contaminated plastic waste, of which we've got plenty, to be converted effectively into food packaging via chemical recycling. And the implications for this, for the world's global waste management and for the environment, really are immense. So on behalf of everyone at IChemE and me, I'd like to thank you for all you've done and been doing to advance chemical engineering for the great benefit of society. I wish you all the best for the future. Well done to all of you in the team. And now, just before I hand back to Matt, I'm going to finish by introducing a short video showcasing Plastic Energy's winning entry.
Okay, so we are producing something like about today more than 1 million tons of plastics every day worldwide. I want to emphasize that this is really plastics are not really the problem. We keep talking for many years that plastics is a big concern, but really the plastic has nothing to do with what we do with the plastics once that we have used it. To the point that right now, this valuable material is we are only recycling something like about 14% of the plastics packaging that is being produced worldwide, with a similar percentage sent to incineration and with about 40% going to landfilling. The problem that we have with this low recycling rates that we have globally is that there are studies that claim that more than 8 million tons of plastics end up into our oceans every single year. Everything they start to be released in the media, and particularly starting about 3 years ago, where the social media start to be extremely aware of what it is happening in different markets, particularly in Southeast Asia and developing markets, that with a situation that it was heavily promoted and incentivized by the ban of China to import a certain type of low quality recycled plastics into China, that they made the European community or USA, Japan, Australia to have to look for alternative places to divert plastics from China to other regions, particularly Southeast Asia, creating a big problem on those regions because they didn't have the infrastructure that we have in other countries to be able to process those type of plastics. So mainly that kick off different type of policies in different countries to try to improve the way that we manage the waste plastics or the end-of-life plastics that cannot be mechanical recycled, either through different type of policies or commitments from the different companies that use plastics within their packaging. So chemical recycling, mainly what it does is to provide a complementary solution to existing traditional mechanical recycling solutions. Currently, for the last 30 years, what we have been doing as a society is to follow the yellow arrow. We have been producing plastics, we have used it, and then sorted or collected, sorted, and then take it to mechanical recycling facilities that they were forced or they are forced to have to separate the plastics by type of polymer. And in most of the cases, they have to wash it, and therefore they have to dry it, and that in order to produce something that can be used a few more times. But as I said before, that represents really something like about 14% of all the plastics that are being used, and everything else is mainly taken into the red arrow, going to incineration in the north of Europe, or landfilling in the south of Europe, or USA, or Southeast Asia. With the problem that part of that is also is leakage to the environment, and this is what we are going to try to avoid by taking all those type of plastics that are not mechanical recycled and take it into a chemical recycling plant that will be able to process them and produce a value liquid that could be used, in our case, as a feedstock by the petrochemical companies to produce new plastics, but with feedstocks in substitution of fossil oil-based feedstocks. Who is Plastic Energy? We have been developing the technology for the last 10 years. We have 2 plants operating in the south of Spain, one of them since 2015, the second one since 2017. And they are operating real operations with more than 330 days per year. And the technology is patented. And we have been evolving from the beginning, 5 years ago, of the concept of producing diesel out of the end-of-life plastics into an output that today we call it a plastic-to-plastic process, which is what we believe is what the market is demanding, and what is going to increase the circularity of the plastics. And we are able to do this through a long-term partnerships that we have with the most important players, petrochemical companies globally. I'm going to try to turn on a video that hopefully we could be able to get to see. And if you cannot hear the video, please let me know, or try to turn it on at the end of the presentation.
Humans have always developed technologies to improve their quality of living. Plastics have enabled us to reach space, have improved agricultural production, and enabled food and water to be distributed in a more hygienic way. They've also revolutionized healthcare and helped to save lives every day. However, our lifestyle also generates serious problems due to the ways in which we use plastics. With a life cycle of less than 12 minutes, the plastics that we use and throw away every day are rarely recycled and end up piling up in landfills or in our oceans and rivers forever. It is estimated that our oceans hold in excess of 150 million tons of plastic, and that almost 70% of the seafood we normally consume has traces of microplastics. If we continue in this direction, by 2050, there'll be more plastic than fish in the sea, and the situation on land will further worsen. How can we manage this plastic wave which threatens our planet's existence?
Plastic Energy has been working to find a solution over the last 10 years. And today, we have good news to share.
Thanks to a unique process, we've been able to recycle the plastics no one wants and which cannot be mechanically recycled to obtain taka oil. It's an oil which can be used to produce new plastics or alternative transport fuel with a low carbon footprint. This technology reduces fossil fuel consumption used to create virgin plastic. This is not science fiction, it's not a project or a dream. It's a reality which is already up and running 24/7, 365 days a year at our plants in Almería and Seville in Spain. It allows people to continue enjoying the advantages of plastic while minimizing its detrimental effect on the environment. This is a new hope for plastic recycling which we'd like to bring to the entire world, and a process which has made us world leaders in the circular economy of non-mechanically recycled plastic.
It is a great sign of hope that this mechanism has been found, and surely there must be more solutions that the brains of scientists can produce that will help us with this appalling situation.
we've created a new technology which is making a big change. A change which on a daily basis inspires and motivates our employees in London, Almería, Seville, and which will enable us to jointly make a difference in a world where using plastic will no longer be a threat. A technology which will help us look after our cherished planet. Plastic Energy, technology to recycle our future.
Okay. So can you see the presentation now once again?
Yes, we can. Thank you.
Perfect. Thank you very much. Okay, so I hope that everyone had an opportunity to have a cup of coffee. The mission of Plastic Energy is really to reduce pollution and by improving the waste management by diverting plastics, increasing recycling, but with a particular focus only in flexible packaging that in order to produce a high quality recycled content for food grade applications. We have signed it with a global commitment with the Ellen MacArthur Foundation in order to process at least 300,000 tons of end-of-life plastics that cannot be currently mechanically recycled, and we are working towards that goal. The type of feedstocks that we can process, you can see it here in the a small picture. We do not have to separate by type of plastics. We can process LDPE, HDPE, PP, and PS all together without any further separation. But we try to avoid and minimize the quantities of PET and PVC. As you can see in the picture, the plastic is heavily contaminated with food and other type of materials, and then we process it and we produce later on like a product that we call TAC oil, TAC, thermal anaerobic conversion oil, which is mainly like a recycled naphtha that can be used as a feedstock by the petrochemical companies in their crackers. The conversion is for every 1 ton of plastics is coming in, we produce something like about 850 liters of TAC oil. The process is very simple. Explain it. Is we process the feedstock coming to our plant through an extruder where we increase the temperature to about 250 to 270 degrees. And then we take it into one of our reactors that is being heated up by either the synthetic gas that we produce within the process, or at the beginning to turn it on, we need to use natural gas. And then it goes through a contactor, distillation columns, and then we produce the liquids. In this process, something very important for everyone to know is that we are energy neutral right after the extruder. So many people have the belief that these type of technologies are high energy consumers. However, we have to realize that after more than 2 years of operating the plant, we were able to really properly use the synthetic gas produced on the process and be able to apply it to heat the furnaces and be able to avoid or minimize the external gas consumption on the process. So the only consumption that we have in our plant is coming from the electricity consumption of the extruder or the utilities associated to the process. But again, as we were talking in the video, this is not a dream. This is not a PowerPoint presentation. And this is really a reality where we are transforming this plastic waste into a very demanded product, TAC oil, that was presented already in Davos in 2019. with a company, with a petrochemical company, SABIC, that processed our pyrolysis oil and produced recycled food-grade quality pellets that it was used by Unilever, Preventions, Walkie Group, and Tupperware. There are many other examples that during this year in 2020 with other converters, Berry, that also produced some products for Mondelez. One of the important things is that we can assure the traceability of the process, and that is the whole process is validated and certified by ISCC Plus, and the quantities of how much material comes in and comes out is done calculated with a mass balance type of approach that is commonly used in many other different industries. The beauty of the whole process is that the quality of the naphtha-like type of output that we produce can replace traditional fossil fuels and are being used for full-grade plastic packaging, which is the main market that we are addressing. More applications is we just started last year with the Magnum tabs in the selected countries in Europe. Now it's been commercialized globally. Also the NORC packaging, in all the cases, fully certified with ISCC Plus. And now recently, a few weeks ago, it was a great initiative led by the Tesco in the UK that using collecting the plastics from the different shops across the UK, they were processed in our plants and then sold the output to SABIC that was able to produce the polymer that later on Seal Air was able to use in order to produce the packaging for Bradbury cheese. Critical is also to address some of the concerns from the different NGOs is what is the life cycle analysis of this type of processes. We have just finalized a few weeks ago an internal LC8 that it was conducted by Quantis following the ISO standards, and the key points of this LC8 analysis are really that our process in plastic energy has a lower climate change impact than incineration with energy recovery, and also a lower climate change impact than virgin plastics. Our vision that together with the mechanical recyclers, we are going to be able to really reduce the environmental impact of plastics once that we have used them, and with additional improvements that we are going to do in our plants, we are going to be able to even improve the current CO2 footprint of the process. Anyone that is interested in this life cycle analysis, please feel free to download the report from our webpage. We have different plans. I'm going to different projects in the pipeline in different phases of construction, with a first project that is going to be alive in the Netherlands late 2022, where SABIC is going to be the partner in that project. Then we are going to also developing projects in France with Total. Is in the UK signed an agreement with Billydor to supply feedstock to develop a project in Scotland. And besides the two plants that we have in Spain, in Almeria and Seville, we are going to expand the capacity of Seville, of the plant in Seville, and also build another plant in Tenerife. And plus other projects in Southeast Asia, where it's not only a question of managing plastics, but in reality is also improving the collection of plastics. That, as an example, in the city of Jakarta, with a similar population than London, only less than 40% of the waste is being collected. And you can imagine that really plastics is not the real problem. The real problem is the collection of the waste in general, but hopefully, thanks to the plastics, everybody's addressing the problem of this type of cities, and it's going to help to improve the complete waste management, and as a consequence, also what is going to be done with plastics. In Malaysia, we have an agreement also with Petronas and also with INEOS as a partner in Europe. This is mainly the presentation that I have. Any information is our webpage can provide additional input, additional videos and information about our process. And thank you very much for your kind attention today.
Okay, then that wraps up the IChemE 2020 Global Awards. Congratulations to all of this year's finalists, highly commended entries and winners. And a big thank you once again to our sponsors, to IChemE President Stephen Richardson, and to you for joining us this afternoon. The 2021 Global Awards will open for entries in early March. So if you've been suitably inspired by what you've seen in 2020, there's plenty of time to think about your entry. But for now, it's goodbye and congratulations once again to Plastic Energy, winner of the IChemE 2020 Outstanding Achievement in Chemical and Process Engineering Award.